Today, we are going to discuss the Weierstrass substitution. What is Weierstrass substitution? This is commonly known as tangent half-angle substitution. So what is tangent half-angle substitution? Usually, whenever we see we see our integral having the rational functions of sine x and cosine x in the integrand. What is that? So whenever we see our integrand have like 1 plus sine x over 1 minus cosine x dx, or like sine x over 1 plus cosine x, how are you planning to solve these type of integrals? Well, you can't with the commonly known integration techniques you learn in school. We have to use something called the tangent half-angle substitution, which is where you substitute t equal tangent x over 2. So obviously, whenever we do use a substitution, we have to find what dx is. In this case, it would be 2 dt over 1t squared. 1 plus t squared. So what about how are we going to substitute sine x or cosine x? How? Obviously, there's formulas for that, so you can easily derive with sine x. It's just 2t over 1 plus t squared. Cosine x is also 1 minus t squared over 1 plus t squared. Tangent x is, well, 2t over 1 minus t squared. So what are these random formulas? I just jotted down. So these formulas are the ones that we are going to substitute into the integral. What's the point of doing that? We are converting trigonometric rational functions of trig into some variable that we can easily solve. In this case, this is t, and it's so much easier to approach than like trying to solve this. We can't even reduce it using trigonometric identities that we learn in school. So now I shall show you an example. In this time this is page 40, and it is example 5. This is for your reference if you have the book. But now my goal is to teach you how to solve these type of integrals. So again, what is this? This is a rational function. This is a rational function that has like trig function. How can we even reduce this? If we had something like 1 minus cosine squared x, then at least we can try to reduce it. But this one, it's so hard. So let's start slowly with the tangent half substitution. So t equals to tangent x over 2. So let's start. We shall obviously try to integrate this. 1 plus sine x dx. So we already know that sine x is just 2t over 1 plus t squared. Cosine x is just 2, or in this case, we don't need cosine x. My bad. We definitely need what dx is. As you see here, it's 2 dt 1 plus t squared. Yep. So now let's just substitute it there. So this is basically just 2 dt over 1 plus t squared over 1 plus 2t over 1 plus t squared. We can simplify it. 2 dt over 1 plus t squared plus 2t. And this is just conveniently 2 dt over 1 plus t squared. We can easily evaluate this. Is the antiderivative of this integral, and when we back substitute, t equal to tangent x over 2 into this, we get minus negative 2 over 1 plus tangent x over 2 plus c. There we go. We have successfully solved this integral by just expressing the rational function sine x in terms of t by just using this golden rule, t equal to tangent x over 2. This is very useful, and we can use it on almost any integral that has rational functions of sine x and cosine x in the integrand. Always remember this thumb of rule.